Hi, my name is Stefan. I've recently graduated from the University of Pretoria with my degree in computer engineering. As part of the final year of engineering studies, each student is given a project. The project I was given was to build a handwriting robot. The idea behind the project was to design and build a robot that can copy the handwriting of someone. And so I thought that today would be the perfect opportunity to show you what this thing that I spent a year of my life building can do. So I designed the robot based off of a 3D printer where, actually, let me stop sharing my screen. That might make it easier. So I designed the robot based off of a 3D printer. So the pen is controlled in the X and Y direction by two stepper motors, and in the up and down or the Z direction by a small servo motor. The head of the printer sits on a set of rails that use linear bearings so that everything moves nice and smoothly. I also have an Arduino Nano that I use as sort of a motor slave driver to communicate with all the motors that I can communicate with serial comms over this USB cable. The whole handwriting process is actually the most important part. I thought that as a software company, we would want to see the software and algorithms rather than all the all the hardware. So the whole handwriting process is actually quite simple. First, I need to start with a sample of someone's handwriting. So if I just share my screen, I have gotten for today a sample of Rudolph's handwriting that we have over here for reasons that we will see later. So first, we start with a piece of handwriting. Now we need to get this into some form that the system understands. To do that, we need to perform edge detection, we need to segment the image, but the first process is binarization. So we take the image and every sort of white pixel becomes white, every sort of black pixel becomes black, which means we end up with an image that is made up of only two pixel values, white and black, with nothing in between. Next, the image needs to be segmented. Here is an example of what this image would look like, or this sentence would look like segmented, where each letter gets a little green block outlining it to show that this is these letters that we're going to extract from what Rudolph has written for us. Once we have it in this format, we can actually crop out each of the little green blocks and save them into a file in a folder. That looks like this. So these are the files and folders generated from Rudolph's handwriting. If we look at the E, for example, we see that here are all his lowercase e's. You'll see that there are multiple e's here. Because of what Rudolph wrote, there are multiple e's in it. This actually helps overcome a bit of a problem that the system has, where when humans normally write, we don't write two letters in the same way ever. And this poses a bit of a problem for the system, as I intend to use these letters exactly how they are to make our new piece of handwriting. So having multiple E's means that every time we need an E, we can randomly pick one so that every E won't look exactly the same as all the other E's, and makes the handwriting look a little bit more realistic. And so here, once we have all of the letters taken out, stored in their folders, labeled, all of that, we can actually use them to make a sentence. So the sentence that I've chosen for today is that all grads pass the security level up. Now we can see why I wanted Rudolph's handwriting for this demo. And so if we run this, what it does is it takes all of those letters that we've used and the sentence that we want, and it puts them all next to each other in a way that makes our new sentence. Now, this sentence generation sort of caused me a bit of problems in the design of the project, where you can't just place letters next to each other. Letters need to be shifted vertically, either up or down, to match the other letters in a sentence. For example, if we have an A and a G, you'll see that the A and the G placed next to each other looks really funky. That's because the G needs to be shifted down slightly. Similarly, an A and an F looks a little bit weird. The F needs to be moved up slightly. And so if we look at our example, the A's, the L's, the H all need to be shifted up, while the G, the P, and the Y's all need to be shifted down. Okay, so now we have our sentence, but we can't write it just yet. All of these letters are made up of lines. Now, to us, they're just lines. It's perfectly fine. But to our system and to computers, these lines are made up of pixels. Those pixels have width. Those width is a bunch of little pixels next to each other. Now, to us, that's not a problem. But to the system, it poses a little bit of a problem. So what I did was we run this image through a thinning algorithm, which converts all the letters into lines that are only 1 pixel wide. So after thinning, our image looks like this, where same letters, same everything, just all the lines are now 1 pixel wide. And now we have something that we can give to the robot to actually write. And here is the part where I need to come clean. Technically speaking, this robot doesn't write handwriting. I know, shock and horror. What it actually does is it draws pictures. And it does that by finding a black pixel, moving the pen to that point, putting the pen down. Then looks around the pen, are there any other black pixels? If there are, moves the pen. If there are, moves the pen. If there are, moves the pen. This process continues until it can't find any more black pixels around the pen, in which case it lifts up the pen, keeps looking, move the pen, puts the pen down, looks for black pixels, moves, looks, moves, looks, moves. This process continues until there are no more black pixels left in the image that the pen hasn't drawn on. So in that way, it's not writing handwriting, it's drawing a picture. But in this context, our picture is a picture of writing. And so let me just show that there is paper in it, because that will make it write significantly better. Okay, with paper in and it turned on, I can now actually write. And so let me just stop sharing my screen so we can all have a nice view of the robot. And then that. Cool. So it starts by establishing connection with the printer and then moving the head into the top left position of the page, because that's where all of our writing normally starts. It then goes through the process I explained earlier, finding a black pixel, putting it down, moving, lifting, moving, putting it down, moving. This process continues, and I will stop talking now so that you can all enjoy the show for a few seconds. And just like that, it is done. So let's have a look at what we have produced. And just like that, congratulations, grads, we have all passed the security level up. And for the people online, here is our result. That looks a bit funky and it's flipped. I apologize. For those online, come see me, I'll show it to you. Thank you very much for listening to my talk.